Okay. So far, for the most part, we've been dealing with problems where order is important. And those were called permutations, right? Or arrangements. Or the question might be worded, how many different words? And they'll usually put words in quotation marks indicating they're not real words, they're just maybe 3 or 4 letters together and they don't necessarily have to make sense. Okay? Or lining up books on a shelf, etc., etc. That's what, for the most part, we've been doing up to now. There are other problems where order is not important, such as selecting people for a committee. So the key words in problems involving questions or where order is not important, the key words are select. How many ways can we select 3 people? How many ways can we choose 3 people? That's all I can think of right now. Determining whether order is important is a critical issue now. There's a little typo there. It determines whether we treat the question as a permutation or a combination. Okay? So again, the words select, choose are combination types of problems. So the key words here, I'll write it here again to make sure there's no confusion. Combination involves words such as select or choose. Okay. Now, recall. We did this formula. This is arrangements when some objects are alike. That's the formula. Arrangements when some objects are alike. Are alike. Okay? So, notice, when there were n objects of which A were alike or B were alike or C were alike, we divided by what was the same, right? If there were A the same, we divided by A factorial. If there were B the same, we divided by B factorial, okay? When objects are alike, their order becomes irrelevant. So if 3 letters are identical in a situation, the solution requires we divide by 3 factorial. Okay? So when order is irrelevant, we divide it by the number of elements where the order is irrelevant, factorial, right? We divided that order out because we didn't want that order to be reflected in our answer. Recall, this was a previous question, okay? We're just recalling because I want you to be able to relate things together. You had a homework question which asked, in how many ways can the letters of the word section be arranged if the consonants must be in the same order, right? In which they occur in the word itself. So S always had to be before C, and C always had to be before T, and T had to be before N. So an arrangement like this would be okay. We didn't, as long as S was before C, before T, before N. So the order of the consonants was irrelevant. So we divided by 4 factorial. Whenever order is irrelevant, we divide it out. Okay? We divide it out so It will reduce the number of possibilities in our answer. So recall, in our arrangement of n things, the formula was n factorial over n minus r factorial. So this represents items where the order is irrelevant. So the number of items not chosen is irrelevant. Irrelevant. Okay, so we divided it out. Okay, so I'm just emphasizing where order is irrelevant, we divide it out. When some objects are alike, we divided it out. When consonants had to be in the same order in which they appear in the word itself, we divided it out. For items not chosen in our permutation, we divided it out. So today we have a new formula for combinations. The symbolism for combination can be n choose r. You can also write it as C for combination, n choose r, or your calculator will most likely show it like this, n choose r. This is all asking for the same thing. Just like when we had the permutation symbolism, we had NPR, or that's equivalent to writing PNR. Okay, just equivalent symbolism I want to make you aware of. So notice the formula is, it has another item in it, n factorial divided by r factorial. When we choose r things, when we have n things to choose from, this becomes our formula. So notice we have n things to choose from. We are dividing by the order of items not chosen as well as the order of items chosen. So notice r is number of items chosen. So we're dividing by that order because the order of items chosen is irrelevant. So we're dividing it out, and is the number of items not chosen. So we're dividing that out as well. So no order in the combination situation is important. We're just dividing out any order. So let's take a look at this. Okay, and I think it's note that not only do we divide by n minus r factorial for the items not chosen, but by r factorial for the items chosen, okay? Because the order of those items are not important. So let's take a look at this. I want to make sure that you understand the difference between combination and permutation. Given the letters A, B, C, and D, how many combinations of 3 letters are possible? List them. So we have 4 letters. So how many combinations are possible? Well, we have 4 letters. We're choosing 3. So you could choose A, B, C, right? You could choose the first 3, or you could choose A, B, D. Or you could choose A, C, D, or B, C, D. Those are the total number of ways you can choose 3 things when you have 4 things to choose from. This is a combination. Just try not to use too much space, okay? So this is a combination where we just choose 3 letters without regard to order. When we have a permutation, not only do we choose the three letters, we also arrange them. So if we have ABC or ABD or ACD or BCD, we're also going to arrange them. So notice there are 4 ways to choose 3 items when we have 4 items to choose from. But here, there's many more ways of getting our arrangements. So our arrangements could be ACB, BAC, BCA, CAB, and CBA. Or if we have ABD, ADB, BAD, BDA, DAB, DBA. ACD, ADC, CAD, CDA, DAC, DCA. Or BCD, BDC, CDC, CBD, or CDB, DBC, DCB. Okay, so now we have, the answer now is 24. So notice we have 24 permutations and 4 combinations. Okay, very different answer. So how do we get those 4 different answers using our calculator? How many ways are there to choose 3 things? When you have 4 things, you go 4, choose 3. And notice there is another button on your calculator for 4, choose 3. Mine is right there. Yours might be above the multiplication or division sign. 4 NCR3, better turn it on first. 4 NCR3 is equal to 4. And that's what we got, 1, 2, 3, 4. A permutation, on the other hand, 4P3 is going to be 4 NPR3, and we get 24. Okay. So that's the difference between combination and permutation. Here, you're just choosing. Here, you're choosing and arranging all in one step. A mathematics competition is held in which a team of 3 students writes for the school. How many different teams can be chosen if 5 students try out? Okay, so how many different teams can be chosen? Notice the key word here is chosen. So we go 5 students to choose from. We only need 3. And if you put that in your calculator, 5 NCR3 is equal to 10. There's 10 ways to choose 3 students when you have 5 to choose from. Okay. A gardener bought 5 geraniums, 3 rose bushes, 4 evergreen bushes from a nursery that had 14 geraniums, 12 rose bushes, and only 5 evergreen bushes. We don't care about what order these bushes go into a person's car. We only care that we bought the bushes, right? Order is irrelevant here. Notice the key word, how many choices. It's not how many arrangements, how many choices. Okay, so we go, there's 14 geraniums to choose from, and we want 5. There's 12 rose bushes to choose from, and we want 3. And there's 5 evergreen bushes to choose from, and we want 4. So it's quite a large number. It's, if we go 14, choose 5, times 12, choose 3, times 5, choose 4, we get 2,202,200. So 2,202,200. Find the number of 4 subsets. Here, again, order is not important. So we're dealing with a combination. So 11, choose 4, and that is 330. Again, now it's sort of, I'm worried I'm insulting your intelligence. They're pretty straightforward. How many dance committees of 5 students can be chosen? Again, the key word is choose. We don't care about order. As long as we have our 5 students, that's all that's relevant in this question. So it's 1,000, choose 5. And it's approximately, because this is such a big number, we're rounding quite a few numbers here, but it's approximately 8.25029,125 times 10 to the 12 choices, so a very large number of choices. How many dance committees of 2 boys and 3 girls can be formed in a school with 480 boys and 520 girls? Well, again, out of the 480 boys, we need 2 boys. Out of the 520 girls, we need 3. And again, it's a very big number, 2.6785 times 10 to the 12. Is there anything I can explain better? Anything at all?